Morning.
Good morning. How are you?
Very good, thank you. Hello, Alejandro. Good morning.
Good morning.
Yeah.
Elias, you can start the class, okay?
Okay, thank you.
Okay, 1 hour, don't forget that. Okay, Alejandro, be ready. The class going to start right now, okay? Welcome.
Okay, today our topic of discussion is about 3 chapters, and the one is about gravity, and the other is momentum, and the last one is circular motion. So, first of all, we will discuss about the gravity. According to Newton, first law, according to Newton law of motion, every body in the universe attracts every other body toward itself. It means that if there is some object having mass m, and there is another mass m2, they always attract each other with the same forces. It means that the same amount of force that will be exerted by this mass on m2, this m2 will exert same magnitude force on the mass 1. It means that the force 1 that is applying onto the mass 2 will be equal to the force that is same in magnitude applying by the mass 2 on the mass 1. So it means that these both forces will be equal to each other regardless of the mass. It means that mass can be or not can be equal to each other. Mass 1 doesn't mass 2. Mass 1 can be larger than M2 and it can be of the same size or matter, but the forces always will be equal. So the formula that Newton explained about gravity, it is F equal to G, that is also called as gravitational constant, and universal gravitational constant, and that is the product of both masses m1 and m2, and the distance from their center to the center of the other. So the Newton said that the gravitational force is equal to the product of the both masses and inversely proportional to the square of the distance between both of these, and this is the distance. So that is the formula we use to calculate the numerical values of the different assumptions. So according to Newton, gravitational force is equal to product of both masses and inversely proportional to the square of the distance. Here G is the universal gravitational constant and its value is equal to 6.67 and multiply by 10 to power minus 11, and its units are basically Newton meter square kg, that is also called kilogram per meter square. So these are the units of gravitational constant, and this is the value of this G. So now we can say that, and we know that Newton's third law of motion, every action has always opposite reaction, and in that consider that is the mass 1, and that is mass 2. This mass, if it exerts a force on the m2, the same force will be exerted by on the m1 by the m2. So the action always will be executed by the reaction by the mass 2. So it means that action applies on the one body and the reaction will be applied on the second body. Both action and reaction can never be applied on the single body or same body. So we can say that Newton's third law of motion, Newton third law of motion is same as gravitational law, because we know that we can consider this is the mass of Earth, and that is capital M. We can consider this is the mass of Earth, and that is a small body on the surface of the Earth. So this will attract this mass of Earth, and the mass of gravity will attract this mass of the object. So both are applying action and reaction on each other. So that's why we can say that Newton's third law of motion is same as the gravitational law. And now we will discuss about the gravitational field. We know that the Earth rotate about its own axis and also to the also against the in the circular motion of the sun. So in the circular motions around the sun, its travel year distance, while against its own motion of axis, it's create day motion. So due to this motion of the earth around its own axis create a field around its surrounding. So that field is called as field, that's called as field force, and its units are Newton per kg. It means that that is a force that is has been created by the earth due to its circular motion or its on axial motion around the axis of the earth. And when another body come into the surrounding of this field force, all the gravity will attract those objects toward itself. So now we will consider the value of G. So this is the G, and we can say that that is the small g, that's value is equal to 9.8, and that is also called as accelerational gravity, gravitational constant, and it is equal to the G M E and R plus whole square. So that is also called as altitude variations in the value of G. And we can say that as an object that is on the surface of Earth, consider that is the mass M, and that is the Earth. And always the Earth create a gravitational force.
You can continue, Laya, because the class going to be safe, okay?
There is no student in the class. Okay. So we can say that that is the mass of some object, and here is a Earth, and Earth always attract another object by the force of gravity. Value of G is equal to 9.8 meter per second square. So this value of G becomes lower and lower as this mass goes up and up of the altitude. So on the surface of, that is the surface of Earth, and on the surface this value is equal to 9.8 meter per second square. While as this mass goes to upside, its value become less. That will not be equal to 9.8. That will be lesser than 9.8. And we can calculate this by the formula here. G equal to the capital G, mass of Earth, divided by radius. The radius is from center of Earth to the surface of Earth, and this radius is equal to the 6400 kilometer, and that is the height of object that this mass have traveled to the some altitude, and that is r plus h, and it is whole square. So we can calculate the value of g by putting gravitational constant here, and we know the mass of Earth also. So we can put the value of Earth radius, that is 6400 kilometer, plus the height of the object that he has traveled from the surface of Earth to the some altitude point. So we can calculate the value of g that has become less by the motion of the object toward the some height. Is that okay?
Yeah, you can continue, Elias. No problem. Es que
So now the topic of is about lights. We can say now the topic is artificial satellites, and we know that the bodies that revolve around the Earth are called as satellites. So we can consider that is our Earth, and here is a satellite that is revolving around the Earth in the circular motion of radius r, and we can say that the radius is r, and that is the mass of Earth, and its radius are here r, capital R. Okay, so this satellite is moving around the Earth in that direction and has height of r, or we can say that height h. So there are some natural satellite and there are some artificial satellite. The satellite that are launched by the human to the space are called as artificial satellite, while the satellite that are by the nature are called as a natural satellite. And the example of natural satellite is our moon that revolve around the Earth and completes its circle in 27.3 days. So that is the time of moon to complete its 1 month revolution around the Earth. So now we will consider the topic of artificial satellites. The bodies that moves around the Earth and they complete their 1 revolutions in a year are called as geostationary satellites. That is called as geostationary satellite. And why they are called as geostationary satellite? Because they are moving around the Earth. That's why the geo word. Geo word means Earth, and stationary means they are always a constant to the motion of the Earth. As the Earth move, the satellite also move in that direction. And this, as the Earth, we can consider the point here by the yellow point. If this point yellow is here and this satellite at that point is here, when Earth revolves and it revolves around the axis, and this point will come at that point, then this satellite will come to the same exact point at front of this point. So we can say that these both points are always at the same point of confront. So these points are also called as constant point, and that is the reason behind the geostationary satellite that always provide information to the Earth station. So that's why these are called as geostationary satellite. So now there is a small derivations about the artificial satellites. We can say that these artificial satellites move by the force of centripetal force around the Earth. The force that is keeping the satellite around the Earth are called as centripetal force. That is F C, and that is equal to M V square over R. So this is the formula of centripetal force. So we can say that this satellite will have mass weight equal to mg, because it is moving in the field force or gravity that is attracted toward itself. So the force, the Fc, that is also called centripetal force, will be equal to the weight of the satellite. When the weight of the satellite will be equal to the centripetal force, this satellite will rotate in that direction, that is called as circular directions of the satellite. So we can put both of these by equal sign, that is m v square over r equal to m g. So this m will be cancelled out by this mass, and this mass will be cancelled out, and the formula will be equal to g v square over r. So here is the formula of orbital velocity. So we can take this radius, and that is also equal to capital R. And this capital R is the radius of Earth from center of the Earth to surface of the Earth. So we can bring this R to this side, and the formula will be equal to V square equal to G capital R. And by taking under root on the both side, we can say that the formula will be equal to V equal to under root G R. So that is the orbital velocity of this satellite, and the orbital that is equal to 9.8 meter per second square, and while this is the radius of the Earth, and the radius of Earth will be equal to 6,400 kilometer, and also we can put this G is equal to as, and this formula will be like that, G m over r. So orbital velocity also is equal to the G m over r. So here is the two formula of the orbital velocity, and orbital velocity is the velocity about which a satellite moves around the Earth and complete it 1 year revolutions around the Earth. And if we calculate this value, it is equal to 8,000 kilometer per hour. It means that in 1 hour, it's complete about 8,000 kilometer distance. So that is the topic of gravity. Now we will discuss about circular motion. So the circular motion start with the angular displacement. And angular displacement is represented by the theta. That is called as theta, and that is called as the value or the distance traveled by the particle from here to here in a circular motion. That is considering an angle of theta about 2 point. If a particle travel from here, we can say that that is the particle P1, and traveling from here to here and cover a distance R and made an angle theta between 2 points, that is called as angular displacement. And angular displacement has the unit of radian also. It's also calculated in the degree, while it is also in the revolution per minute or something like that. There are three units of the angular displacement, and the degree is the SI units of the the radian are the SI unit of the angular displacement. The formula that we use in for the calculation of the angular displacement, that is theta equal to the distance that is traveled per radian. So that is the angle made by the both point, and that is the distance s covered by the point P1 from here to here, and this is the radius from that is from center point to the last point of the P. So theta is equal to the distance, or we can say that it is the arc length. That is the arc length divided by the radius. So the the units of the theta are radian, and we also call it as revolution. So if a point covering a distance of from here and travel a complete rotation from one point to another point, it completes one revolution. That is also called as 360 degree. If this point moving from start from here and then come again to this point by covering all the distance, then it will cover a degree of 360, and the divided by the radius r, and that will be equal to 2r, because here to here is the first is the distance 1r, and when it will reach that point, the distance will be 2r. So we can cut this to this, and the answer will be equal to 180 degree over r. So theta will be equal to 180 degree over 1r, when a body complete one complete revolutions. So we can convert this into radian and degree also. Now we will discuss about the angular velocity. The term is here angular velocity. Until now we have the concept of linear velocity, that is an object covered by when it's travel in the direction of a straight line motion. While when a body moves in a circular path, we called it angular motion because it travel about a radius of r in a circle from here to in that direction of a circle. So uh, we represent this angular velocity by a sign of omega, and it is called as the angular displacement or the angular distance covered by the body in a distance time t. The rate of change of angular displacement is called as angular velocity, and that is used to count the circular velocities of the different objects. We can include an example of the our electric fan. Consider if our electric fan rotates and it cover 3 revolutions. 3 revolution. 3 revolutions mean it's covering a distance one circle, then it's cover another circle, and then also another circle. So that is here we can say that 3 revolution per time t, and so the time we have to be given by the some structure or in the numerical value. We can calculate this value of angular velocity by the data. For conversion of revolution to the radian, we can use this formula for our simplification, that is our 1 radian equal to 57.01 degree. So this formula can be used to convert the revolutions, or we can say that 2 pi radian equal to 360 degree. So we have how many revolutions? 3. We can count here 3 revolutions, and then we can calculate the value of x, and we can put that value here, and we can calculate the value of angular velocity by the this formula if we have time in the numerical data. So now we will calculate, we consider the term angular acceleration. The angular acceleration is same like that of the simple acceleration, that is covered or that is by the body motion of in the straight line, and that is represented by the a, but this angular acceleration is represented by the alpha because this is due to the angular motions of the object around a in a circular shape. So the angular motion of linear acceleration is represented by the alpha in the angular acceleration, and the direction of angular acceleration is always at 90 degree to the linear acceleration. So the linear acceleration will be in that direction, while the angular acceleration will be in this direction. and the direction will be in the opposite direction if if the velocity of the body decreasing, and if the 1 minute. If the velocity, or we can say that angular velocity, that is represented by omega, is decreasing, the acceleration will be negative. That is also called as retardation. Or deceleration. While if the velocity of body is increasing, the value of alpha will be positive, and that is called as positive acceleration, and the direction will be in the same directions of the velocities, mean that the velocity will be in that direction, and the angle angular acceleration will also be in the same direction. Now, the formula we can use to calculate the angular acceleration of the object, that is similar like that we use in the previous linear motions, and that is equal to omega f, omega final minus omega initial. That is final angular velocity, and that is initial angular velocity of the object that is moving around in this circle, divided by the time t, that is delta t. It means that starting from here and after covering some distance, time will be time t. So angular acceleration is equal to the subtraction of final from the into the initial over time, or we can say that rate of change of angular velocity is equal to the angular acceleration. This is the topic about the angular acceleration, and now we will discuss the topic of centripetal acceleration. That is centripetal force, and that is also about centripetal acceleration. And to define this force, we can say that the force that and the body to move in a circular direction is called as centripetal force. And we can take the example of stone that is tied to some thread like, and we can revolve this about our finger. So this is the stone, and that is moving in that direction, and this is the finger, and that is the thread. This thread making a tension in this stone and allowing this stone to move in that circular motion. If we can if we throw this stone in the straight direction, this stone will be travel in this direction, while this finger is causing this stone to move in that direction, and that is by the centripetal force. And the centripetal force is the force that cause the body to move in a circular motion instead of linear motion. So we can have a formula of centripetal force equal to mass of the object. This stone will have some mass m, and it is about radius r from the center of to the some distance of the circle, and have some velocity moving with some velocity in that direction, and that will be the square of velocity over r. That is a long derivations, but we have to just count down the formula for the centripetal acceleration. So here is the formula we can use to calculate the centripetal force that is cause the body to move in the circular directions. And for circular motion, we now that we do not count this linear velocity, and we have formula equal to, and we know that our omega is equal to us. Our omega is equal to our acceleration, and that is called as angular acceleration, is equal to that, and we can have a relation between acceleration and velocity by the v equal to r omega, and we can put this value of velocity here. Simply m come down, and by putting the value of velocity here, r omega data square over r. So we can scale both of these value, that is f equal to m r square omega square over r, and here the 1r will be cancelled out of by the denominator r, and the formula will be like that: fc equal to m r omega square. So this is the formula we can use to count down the motion of a body in a circular path, and we can say that we can calculate the centripetal force or a single force that is exerting on the object centripetal force by the with the help of numerical data. Now we can have this was the 2D motions of the in the plane of horizontal motion. Now we can count down the motion of object in the vertical circular motion, and one can be around the vertical motion. So that we can say that that is the horizontal motion, and that can be the, that is in the purple circle, could be the vertical motion. And in the vertical motion, the stone will move in that direction. We can say that in that direction. While in the horizontal motion, the stone will move in this direction. That will be like that, and that will be like here, that. So we can say that that is the center point, and we can have a thread like this, and here is a particle that is of mass m, and due to gravity, this force is acting on the object, and that will be the weight of the object, like that, w. So that is equal to mg, and some tension that is exerting on the object and causing this motion to be in the center of the body. So we can say that the tension T is here, that causing the body to move in that direction in the circular motion, and while this body want to move in straight line motion. If we release this stone from here, that will move always into the same straight line motion. So we can say that this motion is caused by the centripetal motion, and the centripetal motion will be by the tension and weight of the body. So here the tension is more stronger than the weight of the body, because it does not allow the weight of the body to move in the outward direction. Instead, it allowing it to move in the circular motion. So that we can say that the tension will be higher. So we can minus tension, we can minus weight of the body from the tension, and these have some component about their point, because we are considering the vertical motions of the object. So the point that is causing the body to move in this direction, that will be mg cos theta, and that is the point that causing the angle theta here, and this will be the mg sine theta, and the vector point will be from here to here. So the body always move in the circular direction. So we can put m v square over r here. That is actually the formula of centripetal force, and tension T here minus m g cos theta. So if this stone is at this lowest point, and we can say that this point is C, and this is the top point, and we can say that that is A point, and this is the point of horizontal motion, and we can say that that is the point B, and here is that point, that is like we can say that that is D. So the point D and point B both are the horizontal motions, and we can count down the value of centripetal force by just counting this formula. While for the vertical circular motion, we have to count down this total formula for the calculation of tension, and that will be at point A and point C. And if we consider the point is at highest point, and we can, if we count this point is at highest point and having weight W and the tension T, so we can say that the angle between tension and the weight will be lower, and in the case of if the weight of the body is at lowest point at that point, and that is the tension T here, and the weight of the body W is here, that is always in the lowest direction, weight of the body always toward the lowest direction, while the tension also in this direction will be in the lower direction, while tension here will be in the opposite direction of the upper side. So here the angle is made equal to 180, because these both are in that direction. The tension is on the upper side, while the weight of the body is moving downward direction at the point C. So we can say that that angle is equal to 180. So because this is the total half of the circle, so we can put the value of cos theta 180, and we know that theta is equal to 180 cos 180 cos 180 degree is equal to minus 1. And if we put the value of cos theta, cos 180 minus 1 here, then this minus sign and this minus sign will be added, and multiply by the multiplication we can have minus into the positive term. So this centripetal force will be equal to tension plus mg. So the centripetal force will be higher at that of point C. Similarly, we can count down the angle value from here because both are in the same direction, and we can put cos 0 here, and cos 0 is equal to 1. Sorry, this cos theta 0 equal to 1. And if we put mg into 1, the answer will be like that, T minus mg, and this factor will gone. So centripetal force will be tension minus mg, and that will be at the highest point at A. And this means that the tension will be lower at the highest point. So that is about the centripetal force or centripetal acceleration in the 2D motions of the object in the horizontal motion, and to the vertical motion. And if we want to count the velocity of the object in the vertical motion, we have simplest formula, that is v equal to under root 3 g r plus that is equal to 2g r, and that is equal to cos theta. Similarly, as we have count the value of theta in vertical motion at the highest and the top point, we can count the value of theta here. And if we put theta is equal to 180, our answer will be like that, minus 3g r minus 2g r, because cos 180 is equal to minus 1, and this plus and minus 1 will be equal to minus sign. So 3g r minus 2g r equal to 1g r, and that will be equal to if theta equal to 180 degree, and it means that both the tension and the weight are in the opposite direction. And if the weight and tension both are in the same direction, the theta will be equal to 0 degree. And by putting the value of cos 0 here, the answer will be equal to v under root 5 gr, because that is a positive sign, and we can add both of these together, and the answer will be equal to v is equal to 5 under root 5 gr. These formula are for the vertical motion, or we can say that vertical circular motion. So we can say we have formula to calculate the velocity of the body in a vertical circular motion when at its highest point and at the lowest point of the circular point. And the last term we have, that is momentum. And momentum is defined as the quantity of motion of the object is called as momentum, and momentum is equal to PMV, or we can say that the product of mass and velocity is momentum, and its units are Newton second, and that are the SI units of the momentum. And there are some other derivations about the momentum, and we have to discuss motion of two bodies that are moving in the same direction, but the velocity of v1 is greater than the velocity of v2, and this is v1 and this is m2. So we will count down this procedure for the in the next class about the momentum, and that is a long derivations. Until now, we have cleared the topic of circular motions and the gravitational motion. Thank you.
Okay, thank you, Elias. Have a wonderful day.
Okay, thank you.
Bye.